In our last class, we talked about sources, mainly databases. We need to select the appropriate ones based on our purpose of literature search. In this class, we'll move forward to search strategy. A good search strategy is the core of your literature review. The quality of the search strategy affects what items may have been missed. Literature search and review is a complicated process. First, we need to select appropriate databases and identify relevant search terms based on our purpose of literature review. For example, if you want to identify the research gap, you may consider selecting multiple databases and identify all relevant search terms to avoid missing relevant literature. However, if you search literature to develop your research design, for example, to learn how to recruit participants, identifying all relevant literature is not your priority anymore. A literature search strategy usually combines search terms with Boolean operators. After selecting databases and making a primary search strategy, we will run a literature search and then take a look at the results. The search results may not be as perfect as you expected. In that case, you will refine your search strategy and run the literature search again. You may go back and forth several times until the search results look good. We create a search strategy based on the review question. PICO is a good framework to help clarify your review question. As you know, P means patient, population, I means intervention, C means comparison or control, and O is outcome. For example, we aim to identify literature related to the effects of preoperative exercise interventions on lung cancer patients. Obviously, we have a PIC. Our search terms should include P, which is lung cancer patients, and I, which is exercise interventions before surgery. We can further divide I into two terms, exercise and surgery. So we have three terms now: lung cancer, exercise, and surgery. We don't have a O because exercise may affect various health outcomes of lung cancer patients, including exercise capacity, pulmonary function, postoperative complications, etc. We are searching for evidence related to all the relevant outcomes, so we don't have to restrict the O. However, what if we aim to identify literature related to the effects of preoperative exercise interventions on length of hospital stay among lung cancer patients? That will be a different story. In that case, we are only interested in length of hospital stay. We don't care about exercise capacity, pulmonary function, postoperative complications, whatever. This time, in addition to P and I, we will add an O, which is length of hospital stay. My key point here is we develop search strategy based on the research question. In addition to PICO, we may restrict the type of study in literature search. If you are interested in RCT, we could add RCT-related search terms. If you are interested in systematic reviews, we could add systematic review-related search terms instead. Now let's go back to the first research question: effects of preoperative exercise interventions on lung cancer patients. We have three terms now: lung cancer, exercise, and surgery. The next step is to find synonyms and related search terms. The search terms include index term or subject heading and keywords. Both types of search terms are useful and both of them should be used in your search. Usually, we identify the index term first. The index terms differ by databases, and you will need to identify them in each database. Now let me show you how to identify match terms in PubMed and subject headings in CINAHL. We'll still take exercise as an example. On the website of PubMed, you can find MeSH at the bottom of this homepage. Click MeSH and it brings you to a web page for MeSH term search. Type in keywords in the box next to MeSH and click search. We will use exercise. I type in exercise and click search. Now look at the search results. It seems exercise is also a MeSH term. Click exercise and you will see the definition of exercise, available subheadings, and related terms. If you pull down, you can also find other MeSH terms in the MeSH tree, going from more general to more specific terms. It also allows you to broaden or narrow your MeSH terms. Search a broader term will include all the terms nested under it. So in this case, a search in PubMed for the MeSH term exercise will include both resistance training and preoperative exercise. Click Add to Search Builder, and it will generate a correct syntax in the Search Builder box. And then you can search in PubMed and get search results. Now let's search the subject headings in CINAHL. On the top of the homepage of CINAHL, you can find the CINAHL subject headings. Click it and then type in exercise in the search bar. Click Browse. The result shows a list of subject headings related to exercise. You can click exercise and see what other subject headings nested under it. It seems that exercise is an appropriate subject heading. Physical activity could be also appropriate, but it's not under exercise. They're on the same level in the hierarchy. In this case, you can select both physical activity and exercise, and click Search Database. You can find the search results as well as the correct syntax here. Another type of search terms is keywords. People may describe a term or topic in different ways, and we don't want to miss relevant articles using a synonym which is not listed in our search terms. Take the keyword exercise for an example. Some articles may use the terms equal to exercise, physical activity. Some may use terms that include exercise. For example, physical training, physical therapy, physical education, rehabilitation, prehabilitation. Some may use specific types of exercise. For example, aerobic training, resistance training, strength training, endurance training, muscle training, walking, stair climbing, bicycling, treadmill, yoga, tai chi, etc. There are tons of exercise types. It's not wise to include all of them because some of them may not be suitable for patients with lung cancer before surgery. For example, skiing, marathon running. The key point here is, for exercise, the keywords may differ in different populations under different conditions. We will use another example related to surgery. The search terms could be resection, pre-surgical, operative, preoperative, operable. In addition, we should also include the specific type of surgery related to lung cancer, including lobectomy, bilobectomy, segmentectomy, pneumonectomy, thoracotomy. It's not easy to identify all relevant keywords. Here are some strategies you may use. 1. Checking the title and abstract of relevant articles. 2. Checking the terms from MeSH or subject headings. And 3. Contacting the librarians for assistance. Keywords will be searched in title and abstract, sometimes in keyword section as well, when this function is available. With a list of search terms, the next step will be combining them together using Boolean logic searching. The three basic operators are AND, OR, and NOT. and narrows your results and finds the overlap of the topics. For example, surgery and lung cancer and exercise will generate results when all the three present, or expands your results. We usually use this operator to connect similar concepts or synonyms. The result shows literature in which any of the terms is present. For example, we could use exercise or physical activity or aerobic training. Not is not that commonly used compared to the other two. It narrows your results by excluding words from your search. For example, if we want to exclude animal studies from our search results, we could use surgery and lung cancer and exercise, not animal. Truncation is also very helpful for us to build a search strategy. Take exercise for an example. People may use exercise or exercises. Similarly, you may want to include both behavior and behavior with an extra U. You may want to include both child and children and childhood. Do we have to type in all of them, or are there easier ways to do this? Truncation is very helpful in this case. It's a technique that broadens your search to include various word endings and spellings. Similar to truncation, wildcards substitute a symbol for 0 or 1 letter of a word. For example, we could use WOM ? Instead of woman or women. The truncation is super useful when you want to include both verb and verb ing tense, both single and plural noun, etc. But you may use truncation very carefully because you don't want it to represent lots of irrelevant terms. For example, a student used truncation for terms related to older adults. He identified such terms including aging, age, aging, aged, so he used AG star to represent these terms. You see a problem with this? Does this AG star represent these terms? Yes, it does. The problem is it also represents tons of other terms. Again, aggressive, against, agree, agency, etc. Okay, now we combine the search terms and build a search strategy for PubMed. Here it is. Basically, we combine all the exercise-related terms with or, all the surgery-related terms with or, all the lung cancer-related terms with or, and then combine 1, 2, 3 with and. Let's try to search in PubMed. To save time, we won't type in all the synonyms. I listed related terms in this slide, and we will copy and paste these search terms. On the home page of PubMed, click Advanced. First, we will create a phrase for exercise-related terms. Select title or abstract in the left box. Copy and paste exercise-related terms in the middle box, and select Add with or in the red box. Remember we searched the match terms before? Find them in the history and search details on the bottom. Click the button below Actions and select Add with or. Then you will find the query box showing the phrase same as step 1. Click Search on the right, and you will find more than 1 million search results related to exercise. Click Advanced, and it will bring you back to the home page. We'll repeat it for lung cancer-related terms and surgery-related terms. If you move back to the home page, you will see the query for exercise-related terms, surgery-related terms, and lung cancer-related terms. We'll combine the three phrases together using AND. Click Add Query. Add with AND. Add with AND. Then search. We finally get over 3,000 results. You can browse the results regarding the title and abstract to see whether they are relevant. After initial literature search, we will evaluate the number of results and rate the relevance of the search results. 100, 200 results are reasonable for us to screen, but what if we get only 2 or maybe 10,000? In that case, we will have to broaden or narrow our search based on the existing search results. To narrow your search, you may change some of your search terms using not, add a year restriction, or add type of studies. For example, if we are interested in the effects of exercise interventions on lung cancer patients following video-assisted thoracic surgery, we can then exclude the search results published before the year video-assisted thoracic surgery was developed. If we are only interested in RCT, then we could filter the article tab to randomized controlled trial. Also, be careful when using truncations. You don't want to include tons of irrelevant articles like the AG star example we talked about before. Sometimes we need to broaden our search. To do this, you may add some synonyms which were missed in the initial search. You can also broaden your search, adding more databases, years, or changing from title to title and abstract, etc. If this is your first to conduct literature search and review, I highly recommend you get advice from librarians or search experts. Even though they may not share a same background with you, their expertise in literature search will still help a lot. Now, let's briefly summarize what we talked about in this session. We talked about how to identify search terms and how to combine them together. The search terms include both index terms and keywords. We combine them together using AND or NOT. We also showed you how to run the search in PubMed and how to narrow or broaden the search strategy.